Today, we're going to look at the workflow for designing a Essix retainer. So I'm going to be using the inLab software today. Now you're going to notice in administration, there is no indication that actually says Essix. And it's because there's no particular software that specifically is designed for Essix. That being said, with the splint component from inLab software, you certainly can design a night guard similar to an Essix. And with the new Primeprints ST and SF material indications, you'll notice that in earlier 2025, they confirmed that those two materials can be used for retainers. So in splint application, you will either do your upper or your lower. So you do have to do these one at a time. So in this case, I'll select upper for now. I'll identify Primeprint. If I want a more rigid material, I'm going to use ST. If you want more of like that thermal flex, that soft flex quality, it would be the SF. But for this particular retainer, I'm going to do it in ST. I've brought this in from DS Core, so scan step is grayed out for that reason. So we're not too concerned with some of these steps in terms of, setting the occlusion and things like that, because we're not actually worrying about the bite and stuff. But always good to just get into the habit of being prepared for these steps for when you are designing an actual night guard where the occlusal surface is a little bit more required and necessary. So I'm going to start the splint application now. Step is the insertion axis step that it brings us into. Again, set model axis and prepare model. This is kind of like edit model that was already done in the inLab CAD when I brought my scans in, and then set model axis in with that. That was the last step that I just did. So in this particular case, I'm going to define the insertion path. Essentially, that's what this step is particularly doing. So I stick with the kind of same concepts that I do for a night guard. So I look straight down my occlusal surface for insertion path. And for my upper, I'm kind of bringing up this little target here on the lower left to basically make sure that those undercuts are limited to kind of the gingival third, the kind of height of contour of those teeth. So the next step, the system is going to automatically block out. I think that the blockout that it produces is, very much sufficient. So I don't usually do anything further for this. Obviously, for certain patients, if you wanted to, add or remove some blockouts to have it be a more engaging, retainer or night guard, that's where you can certainly remove some material. But for this particular case, I'm going to leave it as is. Now, when I come into the design, often when we do create our splint, people will do create by plane if they want just a quick proposal of kind of their border. I usually suggest if you are designing this more as like a retainer, more of like an Essix, do create by line, because then what you're going to be able to do is when you're going around with your cursor, you're going to be able to sculpt this around the actual embrasures of the teeth, more like, traditional retainer. Now, if you wanted it a little bit softer, obviously, just don't make it as pointed with your mouse. But this is where you can certainly like scallop it a little bit more. So I'm just going around these teeth all the way around the arch. Now on the lingual aspect, same thing goes. If I want to follow kind of the scalloped, edge, I certainly can. However, if I wanted it to be a more like straight line, I can also do that as well too. Again, however you see fit to design these as more of like an Essix, it's up to the operator, of course. Now, in terms of the ST, it can go as low as 0.8 millimeters for the thickness. So all I'm going to do is I'm essentially going to have kind of when I go into inLab, I'm going to basically change the parameters only when I'm doing either an Essix or a night guard, right? So if I'm doing SF and I'm doing a night guard, I might go 1.5 millimeters of thickness for the soft flex with the flat biting surface plane of occlusion turned on. Whereas when I do a splint, or sorry, an Essix like I am here, I'd certainly be able to, at this point on my right-hand side, let's say I want to bump this down to 0.8 millimeters. And then for plane occlusion, I'm going to check that off. Okay, so now when I hit apply for these parameters, we're going to see that this is going to follow kind of cusp anatomy. Now, there's some people that actually will design their night guards to be obviously like this, and that would be, fine. And of course, that's also one way to do your night guards. But this is obviously a really easy way to create an Essix. So again, the only difference that I'm doing here is under my parameters. I'm changing my thickness to be a little bit lower. And again, the ST, you can go as low as 0.8 millimeters. The spacer, I'm keeping it the same as what I do for my night guards. If 80 microns kind of gives me that, that retention that I'm looking for on a night guard, it's going to do the same that it needs to from an Essix perspective. The only thing I've turned on and off for my night guard is the plane occlusion option, because now what it's doing is it's following the cusp anatomy of this arch. So I'd be able to, at this point, move forward to the finalize phase, and I would export to manufacturing so that it's heading to my CAM software. Now, what I would do if I need to now do the lower, I'm going to essentially repeat the exact same steps by just closing out the splint application, going back into admin in my inLab CAD, and just changing from my upper jaw splint to my lower jaw splint, and then the steps remain the exact same. So that's kind of the workaround if you want to use the inLab software to create a splint, and using the Primeprints ST or SF materials earlier this year in 2025, they were approved for retainer use. So at this point, you can use them with their minimal thickness to basically create an Essix retainer. I hope you find this helpful. Like and subscribe.